In chemistry, we're going to be doing a lot of different math in order to explain chemistry concepts. So I'm going to do a little bit of review of some math in the next few videos of things that you've probably done before in other classes, but we're just going to catch you up to speed so you're ready to apply these concepts to chemistry. So in this video, I'm going to talk about units versus variables and the metric system. So we've looked at the equation for density in a previous video, and we said that density is equal to mass over volume. So these letters right here that we have are D is equal to M over V, and those are called variables. Variables are just letters that represent a specific quantity. So M is something that represents mass, V, capital V represents volume, a capital D represents density, and all of these are defined in your reference table on the formulas sheet. You'll have the formula, and then over to the side it'll tell you what M means and what V means. Now, all of these different quantities can be measured different ways. So we can measure mass in different ways. We can measure volume in different ways, right? But there is an SI unit, which is sort of this standard unit of measurement. It's like sort of the accepted base unit. Mass is a little weird. I'll talk about that. But I'm going to give you some of those for some units that we're going to use in chemistry. So the SI units for volume are liters. Now we can also measure volume as we did in our example problems and in other labs as milliliters or centimeters cubed. It's another type of unit, but liter is the SI unit. And I'll explain when we go over the metric system, what a milliliter is compared to a liter. The SI unit for temperature is Kelvin, but we can also measure in degrees Celsius. We know we can also measure in Fahrenheit. We will never use Fahrenheit in here. We will use either this or this and be able to easily convert between each of them. The SI unit for pressure is pascals. We're in as capital P little a, but we have other units for pressure that we'll use in here called atmospheres and millimeters of mercury. But this is the SI unit. The SI unit for energy is joules, which is Joules, and it's written with a capital letter J, and we'll be using this in terms of heat energy. We've already looked at it in terms of specific heat, and we'll look at the derived unit for specific heat in just one second. The amount of things is a mole, and we'll spend a lot of time learning about what moles are, but don't really worry too much about that for now. And then the SI unit for mass is actually a kilogram. It's not a gram, which is different than all of the other SI units. Gram is considered the base unit in the metric system, but kilogram is the SI unit. Most often, though, we're going to be measuring stuff because we're measuring small amounts of things in chemistry class. We're going to be measuring them in grams and using the unit of grams for mass. All right, so I've mentioned a little bit about derived units, and we'll talk about them again. We already looked at a couple of derived units, and I'm going to talk about the two most important ones for Unit 1. So a derived unit is just when you are comparing two units to define a physical property. So you're comparing just not one individual way of measuring things, but two measurements together. So the derived unit that we looked at already in the density video is just density is equal to mass divided by volume. So what is the unit when we're looking at density? Well, it would just be the unit for mass divided by the unit for volume. So what we used in here was grams, and it's per milliliter. So that tells you how much mass per unit space, right? So this is a derived unit where we're comparing more than one of these. Okay. The other derived unit that we've looked at on the front of our reference table is something called specific heat. And the equation for specific heat is kind of complicated, but I'll just draw it out here for you, but then we don't really have to worry too much about it until way later in the semester. C is the letter that's used for specific heat, and C is equal to Q, which is energy, divided by mass times the change in temperature. Okay, so the derived unit looks like this. J, which is for energy, like we saw up here, per, and then we have mass, which we're going to measure usually in grams, and then in change in temperature here, for our purposes, we'll use degrees Celsius. So this is the derived unit. what this means is the amount of energy per gram to change something by 1 degree Celsius. So a derived unit is just when you're comparing multiple of these kinds of units. All right, so let's then go ahead and look a little bit at the metric system so you're reminded of that, because we will use that a lot. So the metric system is a system that is a base system of 10, right? So it's all based on tens. And you may have learned the little, the thing like King Henry died, unfortunately, drinking chocolate milk. That really teaches you about the prefixes in the base test system of the metric system. So we have kilo, and then we have hecto, and then we have deca, and then you have your base unit. Okay. Then we have deci, which I'm going to write with a little d just to distinguish it from this. Usually this is written with a capital letter D, and this is written with a lowercase. Deci, and then we have centi, and then we have milli, right? So these are all these prefixes that represent different quantities, right? And that's where you get the King Henry died, unfortunately, drinking chocolate milk. Right? So some of the base units that we have were some of those SI units. So liters, right? I'm going to kind of write it down here. Liters, pascals. Remember I said that mass is a little weird. The SI unit for mass is really kilogram, but the base unit is a gram. You'll usually see them only written with this like one letter without a prefix. Okay, pascals, that's how you write it, and it wouldn't have a prefix. So what kilo means that there's 1,000 of the base units in it. So if this is 1,000, this is 100, this is 10, right? This is 1. Then you have deci, that is 1/10. This is 1/100th of our base unit. This is 1/1000th. So milli is 1/1000th. So what that means is if you have 1 kilogram is going to be 1,000 grams. So 1 kilogram equals 1,000 grams, right? Or like a liter is has 100 centiliters in it. So a centiliter is like 1/100th of a liter. So 1 liter has 100 centiliters. Right? Now we can convert between different units in a couple of different ways, and I'm going to show you 2 different ways right here, and one of them I'll go into further detail in a later video. But the first is just by using this to move the decimals. So I'm just going to write this down here again. So King Henry died, unfortunately, drinking chocolate milk. So let's say you have 272.6 grams of something, and you want to know, how many kilograms is that, right? In order to convert, we can just look and see what is our unit here. It's G, which is our base unit. So we're starting here in U. And I just need to move over to the K to figure out how many decimals I need to move and in what direction. So in order to get to K, I need to go 1, 2, 3 spaces over, which means I would take my decimal here and go 1, 2, 3 spaces in the same direction, and I would end up with 0.272 grams. 6, there should be 6 in there. Grams. Oh, sorry, kilograms. 0.276 kilograms in 272.6 grams. All right, let's do one other one. Let's say you have 0.76 and we have decaliters. And we wanted to know how many centiliters that was. Well, we would just go up and we would start on the deca, and I'm going to swoop 1, 2, 3 places to the right to get to the centa. So in order to do that here, I'm just going to take my decimal and go 1, 2, and I would do 3 swoops to the right. And anywhere where I have a swoop but there's not a number, I'm just going to fill it in with a 0. So it would be 760 centiliters. Now, if I was going to perform this conversion using something called unit analysis, which we'll learn about later, it's just a process where you use like this conversion, the fact that 1 kilogram is 1,000 grams in order to go from one to the other. So we would just write what we're given, so 272.6 grams, and we're going to multiply by a fraction that shows this. So that 1 kilogram is 1,000 grams. And since we're trying to get to a kilogram, we would put the kilogram on top so that the 1,000 grams would cancel on the bottom. And so we would end up having these units cancel, and you'd have 272.6. Then you multiply by this fraction, which is 1 over 1,000. So we divide that by 1,000 and get this. Now, don't worry if this was a little quick review of that. Again, I'm going to spend a long video talking about how to convert in lots of different applications, not just with the metric system, using this process, which is called unit analysis. But for now, as long as you understand the prefix and the base 10 system, we're all good.